Hi, Anava. I'm going to help you with problem 1B that had the cosine in it. So I'm going to teach you a little bit about sine and cosine and how to solve this problem. So in a second, push pause so that you get paper and pencil and you can copy and take notes as we go along. So ready for some higher level math. Woohoo! So the problem 1B in the physics classroom said that there was a 15 kilogram mass that was being pulled with a force of 100 newtons, but at an angle of 30 degrees from horizontal. So that means that some of the force was pulling up and some of the force was pulling forward. And the force pulled the object 5 meters in distance. And the problem asked you to figure out what the work was, and work equals force times distance. But the force is not 100 newtons. That's how much force was pulled both upwards and forward. We only care about the part that was pulling in the forward or horizontal direction. So I only care about this amount of force, which is going to be less than 100 newtons. So how do I figure that out? Well, one way, which we did it before, was get out a protractor and a ruler. So if you did this, you don't have to do this now. You would draw a line. Notice I already drew a horizontal line. Then you would get your protractor out and find where it said 30. And then you would draw an angle of 30 degrees. Then you would have to set some kind of scale. You know that this here is 100 newtons. But you probably don't have a piece of paper that's like 100 centimeters long, so you might set a scale of something like every centimeter is 4 newtons. So you would measure out here 25 centimeters, which would represent 100 newtons. Okay, so you would measure this out 25 centimeters, and this would represent 100 newtons. Then you would complete this right triangle, draw this straight down, and then you would take your ruler out and measure this line right here. And this gives you about 87 newtons once you measure it in centimeters and then convert to newtons. That's not as accurate as you can do it if you actually use something called sine or cosine. So how does that work? Well, sine or cosine is a mathematical way to figure out things with right triangles. So I drew a picture of a right triangle here. And you have to be familiar with some of the terms that I've just abbreviated. HYP is hypotenuse. I don't know why I have a hard time saying that. Hypotenuse. And that's the longest side of the triangle, and it's the longest side of the triangle. Then you have the right triangle, the right 90-degree angle here, and then you have our theta angle right here. The side next to the theta angle is called the one adjacent, and the one opposite the theta angle is called opposite. So those abbreviations, OPP is opposite, ADG is adjacent. So you have 3 sides to this triangle, the hypotenuse, the opposite side, and the adjacent side. And cosine theta is defined as the adjacent side length divided by the hypotenuse side length. And sine theta is defined as the opposite side divided by the hypotenuse side. So how can we use this to solve our problem without a protractor or a ruler? We're going to use the cosine one. So why did I pick cosine? Because I cared about this part of the force. We had 100 newtons here, but I didn't want how much force was going upwards. I wanted to know how much force was going horizontally. So I want to know how big this side of the triangle is, and that's the adjacent side. So cosine theta equals the adjacent side, which I don't know, but I do know the hypotenuse. Also, now I can take out my calculator, and if you don't have one, there's always some available online, and I plug in cosine, and now I know the theta, which was given to us in the problem, is 30 degrees. So you plug in the calculated cosine, and usually it has parentheses around it, and you plug in the number 30 and then hit the equal sign, and it will get you this number, 0.866. It probably has some more digits past that, but that's as many as we need to use for this problem. So now, once again, what do I do with that information? That tells me oops. Let's go back. So what does that tell me? Well, I still want to know what this adjacent side is, right? What is this adjacent side? Well, I know that cosine of theta equals 0.866. And I know that the adjacent side is unknown. So I'm just going to say adjacent. But I do know the hypotenuse, which is 100. So now I have 0.866 equals adjacent over 100. So how do I solve for adjacent? I multiply both sides by 100, and I get 86.6 equals adjacent. So I took this equation here, sorry, this page is getting messy, and multiplied both sides by 100, and I get 86.6 equals adjacent. So how did we get that again? I took the cosine of 30, which is 0.866, and then I went back to this equation and plugged in the numbers I knew. I now know the cosine theta is 0.866, which I got from the calculator. I know that the adjacent side is still unknown, and I know the hypotenuse is 100. Then I solve for adjacent, and I get 86.6. So now I go back to my original problem. I want to know what the work is, force times distance. I now know the force going horizontally, which is the only force I care about because the work is being done horizontally. So the force in the horizontal direction times the distance in the horizontal direction will give me the work done in the horizontal direction. So I have 86.6 newtons times 5 meters. The 5 meters was given in the problem. That's how far the object was moved forward. And I take out my calculator and put in 86.6 times 5, and I get 433 Newton meters, which is also called joules. And there I have it, the answer to the problem, and you used cosine for the very first time. Hope this makes sense. Ask me questions if it doesn't. Hopefully do physics today. See you later.